Here we go. All right, here we are into week 2, continuing to go along. I assume maybe you've seen this morning, I did send out a notice that I bumped our test next week to Tuesday. Just makes sense the way things are going, and we have time later in the term. I make it up, you might say. How's it going? I always start with, who's got a question? Anybody want to ask a question about stuff that's going on, what we've been covering? Let's see. Tara, are you doing okay? Looks like I got some funny connection here or information. Are you totally connected?
I think so.
Yeah, okay. Well, there it goes. Good. Just looking at it says, oh, you're all muted and there's some asking me to do something. Anyway, good. All right. Nobody really sent me a question about how to, I take that back. There was one person having issues with sending in their hand in homework. Hopefully that was resolved. I'll start looking at those today. It might take me a couple days to get through them all. It wasn't a big worksheet, but just don't expect immediate results. Okay. All right. So if you're doing okay, we're going to keep going today. Section 1.9 is referred to as properties. These different properties that we use actually in sort of manipulating our expressions, and eventually when dealing with equations, the distributive property in particular is one that we use a lot in simplifying the expressions in those equations before we do the solve part of it. So the first one that we usually talk about is called the commutative property. The commutative property. And I try to come up with helpful, concepts to help you keep these straight. When you're commuting, you change from one location to another when you commute. And this property is related to the position or location of values in an expression. And it applies to both addition and multiplication. These are considered commutative operations. It basically says the order in which you perform the operation doesn't change the result. 3 times 6 is the same as 6 times 3. You can change the order in which you perform a series of multiplications or additions. Sometimes it's helpful to move things around and do certain things first. It's basically what the commutative property says. The order doesn't matter. So what if I was doing something like 1/2 times 9 times 2? Like, 1/2 times 9, okay. But I could actually change the order and say, I'm going to do 1/2 times 2, and then the 9. Oh, that's easy. That's a 1. 1 times 9. So I'm really kind of making up something. But here's a situation where if I just sort of change the order, even if it's mentally, even if I kind of did that in my head, 1/2 times 2, the result is going to be the same. And the same for an addition. What if I've got a string of fractions like this and I'm supposed to add them all together? -2/3 plus 1/2. I'm going to get a common denominator. What if I switched them around? -2/3 plus 2/3. Well, if I add those two first, that made that a little easier. Sometimes there's reasons where it's helpful to change the order. Just makes your life a little easier. Okay, so that's what we refer to as commutative property of multiplication or of addition. Change the location of that string of operations doesn't change the outcome. The other one, the next one we talk about is associative. The associative property. And again, this one applies to multiplication and addition. You know, back to commutative for a second, you know, you can kind of make sense. It doesn't work for subtraction, right? 5 minus 3 is not the same as 3 minus 5. That's 2, but that's negative 2. So only these two work for addition and multiplication. Okay, so here's my little helper idea. Commutative, you changed location. Associative, when you associate, you're creating a group. Who do you associate with? Who's your group? All right, so it's the grouping idea. So if I have an expression and it contains this series of additions, but for some reason, a couple of them are grouped together, our order of operations would tell us, oh, we should do that thing first to get our final result. But for addition and also for multiplication, if you group different members together, it doesn't change the outcome. So if I took that same example and said, well, what if there was a reason why I wanted to group those two together first? I get the same result. So the property says, if you've got this string of similar operations, it doesn't matter which ones you group and do first, because we kind of can't do all three at once in our head. We really kind of do one part of the operation, almost really, even without the parentheses. We do one combination and then we do the next part of it. Again, let's see, we can make up some situation where it really kind of makes life easier for us. Okay, here's the string of fractions. For some reason, these two are grouped together first. It's like, oh, okay, I got to add those two fractions. I need that common denominator. Well, I should have thought about that just another second, rearrange them a little bit. Allow me to here, even within the parentheses, okay? Here I'm just using commutative property within the parentheses. I commuted within the parentheses, just switch position. Hopefully you'll see why, because now I've got the fifths together. Well, what if I group it differently? Here's the associative property says, well, if I choose to group these two together first, I'm going to get the same result. Well, yeah, why would I do that? Because, well, that's fifths plus fifths. That's easier. So that part of it would have been, then I get 2/3 plus what, 7/5. Now I still need a common denominator to finish this problem. Hopefully you're okay with that. I'll keep going otherwise. But the point was, you can change what you group out of that string of operations, and it won't change the outcome. If I really worked at that common denominator first here and then added that other one, it's going to be the same as if I finished up this one. So a commutative and associative, just ways for us to kind of move things around to make it a little more convenient. All right. One way that that comes in handy thinking about an expression. Let's see, 3 minus 5 plus, I don't know, 11, just make it up. Now, to begin with, this doesn't look like a bunch of addition, right? We've got the subtraction in the middle. But remember, we could think of this as 3 plus -5 plus 11. Well, now it is a bunch of addition. So I could use commutative and say, well, I'd rather do 3 plus 11, and then I'll add the -5. You know, so you could, here's where, oh, I really can add these two together first and then subtract the 5. Because I can interpret it that way. And that's just using the commutative property. All right, so there's a couple problems might ask you to use the commutative property or the associative property to simplify an expression. So they're kind of suggesting you can move things around yourself and then come up with your final answer. Or not unusual for a problem to be presented and say, All right, which property did I use if I went from this step and then I moved the parentheses? Which property was that? Oh, that was associative. Or I went from this step and then I moved things around. Which property was that? That was the commutative property. So you can see questions like that. Honestly, in MOM, I looked at your homework. I think almost all the problems in MOM for this section based on the distributive property, which is the one that's probably we really use most often. We'll get there. We'll get there. All right. So another couple properties, though, that we just introduced because we'll use them a lot, especially when we're solving equations. And the next one's called identity. Ooh. Come on, my pens are dying on me, like say, especially new ones today. There's a good one. We refer to, again, for multiplication and addition, there is what we call an identity number or element or property. Every number has an additive identity. Oh, I'm getting ahead of I'm mixing my properties together. Has an identity element. And the concept here is there's a number I can always add to anything and it doesn't change the anything. Well, that's maybe obvious. I can always add 0 and it doesn't change what I added it to. Like, duh, okay. Well, when we're solving equations, that's going to be handy. And I'll get more specific about it next chapter when we're using it to solve equations. So 0 is what we say, the additive identity. Spell is the additive identity element. It's the additive identity number. It doesn't change what you add it to. All right, just file that away. I can always add 0. But it means in an equation, something like, if I end up simplifying the equation and I get to a point where I say, this unknown value plus 0 equals 5, well, the 0 doesn't change what I'm adding it to, so this really just means the x is a 5. And we'll be able to drop it or ignore it if we can get to a point where we have a 0 in our equation like that. Okay, identity. Similarly for multiplication, there's a number we can multiply everything by, and it doesn't change what you multiply it by. Well, what number is that? It's the 1. 1, that's supposed to be a 1. 1 times 7 is just 7. We can ignore the 1 if we get to that point. Again, eventually in equations, if I can somehow simplify my equation down to a point where it says 1 times the thing I'm looking for equals 3. Well, the 1 doesn't change it, so that means the thing I'm looking for is a 3. That's gonna be sort of a process. We don't actually always end up writing it out like that, but we have to understand that that's a rule that works. Mathematicians have process and rules for everything that justify everything we do. So 1 is the multiplicative. I don't like that word. Multiplicative identity. 1 is the multiplicative identity. Doesn't change what you multiply by. Okay, so again, file that away. We just know it's a property, it's a rule that works. All right. I almost went down this wrong road here when I started that. The other sort of one that works together is called inverses. And again, multiplication and addition both have an inverse property, an inverse number. Every number has an additive inverse. Additive inverse. And basically, they're the numbers that have opposite signs and they add up to the identity 0. So 2 plus something equals 0. Well, what's the opposite or additive inverse of 2 is -2. It's simply that. For addition, these two numbers have opposite signs. And if you add them together, you get to that 0. Maybe you can see where we're going with equations. If I've got some number in my equation I don't want anymore, I'm going to add this inverse so I can get to 0. And then I know the 0 doesn't change anything else. So additive inverses are just positives and negatives of the same absolute value. Multiplicative inverse. All right. These are two numbers you can always multiply together and you get the multiplicative identity. You get 1. 2/3 times something equals 1. It's kind of like, what do we multiply by to cancel it out and get to 1? It's always the reciprocal. So the reciprocal, the flip it over number, right? The 3's cancel, the 2's cancel, and you get to that 1. So every number other than 0 has a multiplicative inverse, the reciprocal. If I, 4 times something, so it cancels out the 4 and I get to a 1. Again, if you think of that as 4 over 1, the reciprocal is 1/4. All right. Again, in an equation situation, what if I've got, 5 x's equals something? Well, I want to get rid of that 5, so I'm going to multiply by its multiplicative inverse. If I multiply 1/5, I get to 1x, like I described a minute ago. Not going to dwell on that right now. That's, what we do a lot of in chapter 2, solving those equations. But we're going to use this property consistently, although we don't bother to write it out all the time. That is, a certain amount of it we understand. We're going to do this, and we know how it works. Identity element, all right, it's that number that doesn't change what you multiply or add it to. And the inverse property is the number that you add to get to that identity, or multiply by to get to that identity. They kind of cancel each other out for those operations. Again, kind of file those away as properties that we use. A problem, I think I recognize, maybe there are some problems, at least it was in book homework, where they'll just ask you what would be the multiplicative inverse of some number. What would be the multiplicative inverse of 7/8? What do I multiply it by? Multiplicative. It's reciprocal. The inverse is 8/7. Or what's the additive inverse of -4? The opposite sign, +4. Okay. All right. Moving along. All right. 0 property. All right. Let's see. All right. 0 multiplied times anything is 0. Okay. Hopefully that's pretty clear. 0 times 5 equals 0. Now, dividing, all right, dividing by 0. Or let's say, let me not get there just yet, but so 0 times 1/4, all right, 0 times 1/4, still saying that equals 0. Well, how about if I think of that as like 0 over 1, that turns into 0/4. Now there I can say, that's a division problem, right? It's 0 divided by 4. 0 divided by anything is still 0. It's really, I can say division is really like multiplying times that fraction. So you can divide 0 by anything, and it's still just 0. How many what's 1/4 of 0? It's still just 0. Okay. Okay, but what about dividing? What do you get if you divide 4 by 0? 4 divided by nothing. Well, it's undefined. There, you just say, oh, can't do that. It's undefined. Let's see if I say 9 let me pick a different number here. 8 divided by 2 equals 4. We can say, we know that's true or it works because 2 times 4 equals 8. Sort of turn it around and turn it into a multiplication problem. Well, if I have 4 divided by 0 equals something, that means the 0 times something equals 4. Well, we just agreed. 0 times anything is just 0. So you can't do that. You can't divide by 0. That'll be a trick question almost. It's like in a homework problem. What's the value there? And there's probably a pull down tab or something. You say undefined or 0 or blah, 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 and it's undefined. Can't divide by 0. If you get there, you're out of luck, in troubles, maybe. Okay, and leads us really to our big deal, distributing. So what if I see an expression like this? This is, as an order of operations problem, it says, oh, let's perform this inside operation, and then I'm going to multiply. I'll get to my 16. But what does multiplication mean? Multiplication is repeated addition. This is saying I want to add 2 of those together, right? 3 plus 5 plus 3 plus 5. Do you agree that means the same thing, right? Well, using commutative and associative properties kind of in your head, you see I could say, oh, that means 3 plus 3 and 5 plus 5. Just kind of mixing them around. Well, that's 2 times 3 plus 2 times 5. Right, 16, still got to the same answer. My point is getting to this. Well, if I go back and look at this, look at the similarities, I kind of got rid of the parentheses here. This, the distributive property kind of says I can distribute this outside factor to each term inside the parentheses. And it's called the distributive property of multiplication over addition. And if it's a subtraction sign, remember we can think of that as adding an opposite. So it might be negative inside there too. But this means 2 times that number and 2 times that number. And I'll use my little arrows like that when I talk about it a lot. You don't have to do that. It might help you on your own homework though. So that turns into 2 times 3 plus 2 times 5. And there we are, we get the same thing right there. Now you might say, well, whoops, why wouldn't I just make that an 8 first? Well, we're gonna run into expressions where there's a variable in there for one of those values, and I can't actually put them together, but I kind of want to simplify by getting rid of the parentheses. Here's the way you might say we will really more often use it. Right? I've got 2 of this expression that has the variable in it, and let's say I got an extra number out here, and I want to simplify this expression. Well, here's some 7s that are being added, and eventually wouldn't I like to combine those constants? But that's trapped inside the parentheses. And there's no simplifying I can do inside to kind of just get rid of the parentheses. So that's where the distributive property helps us out. I can do 2 of each of these, and now it's a string of addition and multiplications, but no more parentheses. So that becomes 2 of x's plus 2 of the 7's. There's the distribution. And now I can follow my order of operations rules and say, oh, so simplifying this expression, I can get down that far. Notice I'm not trying to solve. There was no equal sign. X could still be any number I decide to put in there. I've simplified this expression using that distributive property. Excuse me. Again, this is the way we'll use it most often, with variables in there that are kind of stuck unless we use distribution. Do it again. And just make up some things. Simplify that expression using the distributive property. Notice I made up, I actually took it off a worksheet here, but used a different variable. Could use any letter you want, really. So 8 of these things and 8 of those things. So that's 8 of the 4y's, 4y plus 4y plus 4y plus 4, So 4 times 8 says I have 32y's. Oh, I hope you don't mind that I just did the multiplication in my head. You can do that. I would think you might do that yourself normally. And 8 times 9 is 72. 8 times the 4, 8 times the 9. That's what I did. Right? There it is. I can't put those. Those are not like terms, right? This has a variable, no variables. I can't combine them any further. I'm done simplifying that. Here's another one. Happen to have some fractions in it. Well, I'm going to do 9 of this one and 9 of that one. And notice this one has a minus sign in it. I'm adding a negative. So it still applies, this property. This one I will write out again because this is now going to be 9 times 5/9 x. Notice I kind of wrote it like that because I'm going to say, think of that like 9 over 1 minus 9 times the 1/3. There's my 9 again, like setting it up like a fraction so I can see how I'm going to simplify. That's kind of nice here. The 9's cancel and I get 5x minus, here, how about I cancel some 3's and I just get a 3. So I distributed 9 times each term. Sometimes an expression will have more, we'll see mostly 2 terms, but it could have a very, very large number of terms inside. I multiply every one of them times that outside number. Doesn't matter if that multiplication factor is on the other side, right? Commutative says actually, here's one number times this other number. I could just switch places, commutative property. So I could, you might say, distribute backwards. 6 of those and 6 of those. 6 times the 4 is going to be 24 x's minus 3 times 6 minus 18. Just distributing. Maybe the number outside is a negative. Well, that means I'm multiplying both things inside times -5. Bring the negative along. -5 times 2 is -10 of these x's. -5 times 7 is now -35. All right, distribute the negative sign as part of that number. And if we happen to have a minus inside, we're going to end up multiplying minus times minus, and that'll turn positive. But negative 3 of the x gives me negative 3x. Negative 3 times negative 2 turns to positive 6. Minus times minus, same signs, positive number. Slow me down if necessary. Okay, they can get more complicated, of course. Let's see. Oh, yeah, this is a good one. Good thing to talk about. Now this kind of looks like one expression minus this other expression. How do I simplify that? Well, here, let's assume this one kind of has a 1 in front of it. Or there's nothing really to distribute. 1 times the stuff inside is just the stuff inside. It doesn't change it. This also can be thought of, should be thought of as having like that 1 there. And so this is my negative 1 times both of those pieces. So in a sense, you're distributing the negative sign to every term inside. So this is just going to become 5x minus 3. But here it's minus the x and minus the 7. So I'm subtracting both of those numbers inside. Distribute that negative sign. This is the one that trips people up if they forget to distribute the negative to every piece inside. Now I've got some like terms. And here's where I'm going to use my commutative property. I've got 5 x's, and here I'm adding a negative x. So I can kind of just say I have 5x minus x and get 4 x's. And here I have minus 3 and minus 7 more, minus 10. Let me know if that threw you for a loop. You know, if I want to justify that a little more, remember I could write it like this. I could make it all a bunch of additions, a positive, a negative, a negative, a negative. I'm adding a bunch of things, which means I can move them around. I'm adding a positive and adding a negative. I'm adding a negative and I'm adding more negative. Whoops. Similar. Here's 2 expressions. They both happen to have a factor multiplying. This is a multiplication, and here's a multiplication. Two separate multiplications according to order of operations rules, right? So I'm going to multiply 14 times each of these, and I'm going to multiply negative 8 times each of those. 14 x's minus 14, whoops, minus 14. Negative 8x minus 48. I distributed the negative 8 times that other factor. Again, I've got some like terms to combine now. How many x's do I have? 14 minus 8, all right, 6. I have 6 x's left. Negative 14 minus 48 more, negative 62. Yeah. Okay. Here's the one kind of, I always make sure I kind of do at least one like this, because this is the visual one that messes people up. Oh, 6 minus 3, that's 3 times this. Nope. This is subtraction of, this is multiplication. Order of operations says I have to do that part separately. I have to do that first. I can't just, add or subtract those on the outside. I can't do that first. This is multiply first. So the 6, can't touch the 6 yet. But minus 3 times each of those. 6 minus 3x minus 6. All right. I distributed this to both of them, including the negative. Like terms, just happen to have a positive 6 and a negative 6. They cancel, they get to a 0, so I ignore the 0. That's that inverse property there. So I really just have negative 3x's left. All right. And let's see. That's supposed to look like a 7. Here I made up something with a couple layers of grouping a order of operations problem. Well, I've got brackets because inside of the brackets I have another grouping with parentheses. So always work from the innermost grouping, simplify starting inside and work your way out. For a problem like this, just rewrite what you're not working with yet. Don't try to do too much at once. I'm going to do this, but I really can't simplify this, so I'm going to end up distributing as my first step. Notice I can't do 5 minus 7. That's just what I did a minute ago. You can't do that. This is multiplication. But this 2, I'm not doing anything with. This 5, I'm not doing anything with. Now I'm doing negative 7 times both of those. Negative 7x's and negative 28. Okay. Now it is true, this could just look like a distributive problem right now. I think it's going to end up being 1 anyway. I could do 2 of each of these numbers and get rid of the brackets. That's legal. That's the distributive property. But maybe you'd rather simplify inside the brackets, follow that sort of order of operations rule. That's no problem. 2 times, constants, 5 and negative 28. Negative 23. And I haven't touched the x's. All right, so I did what simplifying I could inside the brackets. Now I have to distribute 2 of this and 2 of that. So negative 46 minus 14x. And that would be done, simplified. Maybe just notice if at this step I had decided to write that as negative 7x minus 23. If I just decided to put the x first and then the constants, it's just commutative. It doesn't matter. These 2 would have been switched. Still the same values in the expression. That's really everything in 1.9. We might kind of, oh no, that's too bad. There's one guy that tried to join us. Jeremiah, hello. I'm sorry you've kind of missed most of the day. I'm really almost done. You might want to go back and watch my recording once I post it. I just noticed that you entered after I started. Sorry about that. But there, I've really gone through our 1.9 material, commutative and associative properties, identities and inverses, and then a fair amount, the real work, the real applications come when we start distributing an outside factor times those terms inside. And like I said, I looked at the mom homework for 1.9. I think it really is just a whole bunch of distribution practice, because that's really the one we're going to use the most. So I'm gonna let you go at this point, unless you have questions you'd like to ask me something. How you doing? Tara, yes. Is that a buy or is that a question?
What's the question? During the distributive, so if you have parentheses on both sides and a number in the middle, you don't distribute that number to both parentheses, right?
And let me see if I understand what you're saying. Let's say this kind of idea that you mean?
Yes.
This number in the middle?
Yeah.
That number is only multiplying this part.
Okay.
That's your question, right?
Yes.
Yes. So this one really doesn't have anything multiplying it other than a 1.
Okay.
There'll be 2 of each of those. I usually talk about, let's say, distribution as you distribute multiplication over the inside additions. Imagine 2 times 3 times 5. You know, when we do a string of multiplications, once we multiply those together, we're done with that 2. We don't distribute the 2 here, and we don't distribute multiplication over multiplication. Okay, I just really like to make that point. You only distribute multiplication over added or subtracted pieces and inside of parentheses like that. Okay, anybody else? Question?
Thank you.
Was that my thank you? If no more questions, then we're going to stop a little early today. Next 2 days, tomorrow we'll look at unit conversions. Change ounces to gallons, feet to miles, and then eventually we do, you know, can you change feet to kilometers between metric and the English system? That's tomorrow. And Thursday, that's a geometry section. It's not like a high school geometry class would have been. It's really geometric figures. Find the area or the perimeter, use formulas. And you should look for the formula worksheet in the mom homework. There's a link for the worksheet, the formula worksheets, both for the unit conversions and the geometric formulas. But so those are kind of, you know, a couple big topics. It's sort of unfortunate. It's kind of the way these chapters always work. We start with the basic concepts for the unit, and we work up to the hard stuff at the end. Right now we're really applying it, and maybe it'll even be word problems eventually. Now we work up to how we really use this in more complicated situations. And oh, okay, now here's the test. So I always plan a review day, you know, before the test, so that we have time to get through that homework and have questions at least and come back another day before the test. So I wish we could, you know, like stretch the class out almost twice as long sometimes, so we just have really time to absorb it, but it's not the way they work, right? Okay, folks, well, it's all for today then, and see you tomorrow. All right? All right, take care.
Thanks, Steve.
Thank you. Yep, bye.